Good evening, students. How are you doing today?
Even, sir.
All right,
Even
easy.
sir, not too bad, no sir.
Nice, nice. Look random.
Good afternoon.
Hi, Rahim.
Hi, good evening, everyone. Not doing too bad, sir. Doing good.
Easy touch.
Good evening, everyone.
Sir,
Sir?
kind of half blind, sir. So can increase this font of that, please, sir. I respect, sir.
Evening, sir.
Good evening to you. Okay. What is your answer? Anybody
Sir,
got an answer? Okay.
yes, sir. One.
I got one. Who is that talking to me?
That's Kayum, sir.
Okay, so Kahim got one. Anybody else?
I got one as well, sir.
Very good. Wayne. Lakarna, what you got, Papa?
One get there. One make
Okay,
there.
nice. Mando, what you get? Amanda? Right. Lawrence, what you got?
I just not too long started working on it. Give me just a bit.
Okay.
Sir, I'm a bit
You got what, Julian?
I'm a bit confused.
Okay, where are you confused?
The factorizing, sir. I think I'm stuck there.
Okay. All right. Rajay, what did you get?
Sir, evening, sir. I just joined a few minutes ago, so I'm still working on it.
All right. I'm gonna give you guys. I won't tell you if the one is correct. I'm gonna give you guys 2 more minutes.
Sir, 2 more minutes is just fine. Give me just a second.
All right, no problem. All right, guys, I have a slight issue. I cannot find my writing pen. I don't know where I put it. So I'm not able to write and do the question, Julie. I wanted to do the question for you, but let me just check one more time. I have everything else away from the pen, but the rest of you said that you wanted 2 more minutes to do the question. What answer did you get, please? Did I put a pen, Lord?
Sorry, I might be wrong, but I got 3.
You might be wrong, but you got 3. Who is this?
Okay.
Logan? All right, so I'm gonna call, thank you, Logan. I'm gonna call Amanda again. Amanda, what did you get for your answer?
I think I'm currently in traffic going home.
Yeah, but answer me to me that no money. Look how long I call.
I'm on Long Hill and the service is very bad, so I didn't hear.
Okay, then I forgive you. Alrighty then. Dujon Anderson. Why is that name? Is the first time I'm seeing that name. Is this your first class, Dujon?
No, sir, no bother with that. I answer a couple questions already.
No, me never said you didn't answer no question. Me said the first me I see your name.
Okay,
I'm go through my list.
still left on the way home still, so I'm gonna get to do that question yet.
All right. Nigel, where you get? Nigel,
Yes, sir.
where you get?
Yes, sir. I'm still at work. If you get a decimal wrong, sir,
It
that
depends.
might be one answer to that soon.
No, I said nothing, and I just said it depends. No, this is very strange. Very, very strange. I just gonna find a pen. Yeah, very strange. Oh, man. All right. I don't like the idea when I give you questions, me turn on under the questions. And when me give questions, the questions are yours. Julie, you finished the question yet? What did you get?
Sir, did you call me?
Lawrence?
Sir, I'm still stuck. I'm
Yes,
confused.
you're confused. All right.
Yes, I'm the factorizing part, sir. I'm confused right there, just there.
Okay. All right. I think this is it. I don't know. When you multiply the coefficient of x squared by the constant, what's the coefficient of x squared? Uh-huh.
Sir, I'm at factorization as well.
Yeah, the factorization to times it to get 5 and we add it to get 3. I don't know about that.
Coefficient of x squared is 2, sir.
Okay, thank you for answering that question for me. So the coefficient of x squared is 2. Because I'm not answering the question I'm asking you. Coefficient of x squared is 2.
I never hear it.
What is a constant term?
3, sir.
Good.
3.
So when I multiply the coefficient of x squared by the constant, what do I get?
3.
No,
6.
I get 6. I need two numbers. When multiplied together will give me 6. But when I add those two numbers, I get 5. What two numbers are we talking about?
2 and 3.
So I get 6. It's because the 2x squared you're taking the 2 from and do it with the 3.
Yes, ma'am. So listen my story again, please. I want you to listen
But
up.
I thought it's always the middle part you do. All right. Okay, sir.
Logan, read that for me, please. I'm sure I projected that in class before. Have I?
No.
You're saying that I didn't do this in class before?
Okay. I don't remember what that, sir. Because the last class is x squared minus 5x plus 6. And it said that the middle one, which is the 5, negative 5, when you times when you subtract it or something, like -3 to -2, you get -5, and when you times it, you get +6, something like that. So, yeah. Anyone know
There is no
do
way there is no way absolutely I could move to where I'm at just now and did not show you this recall. I'm going to ask the question again. Did I
Yes.
ever project this recall to the class before?
Yes, sir, I did.
How to
I
factorize,
remember
sir?
it.
Wow. Guys, you're making this very difficult for me. You're making this very difficult for me.
Sorry, you said you can't work it out this class?
I can't work it out. What do you mean?
No, sir, because you said you're missing the tool to be able to write on
Oh
the
yeah, I can't. Yeah,
document.
I can't find my pen. But I'm just I'm a little concerned because I know I have done this with the class before, and I'm not getting the overwhelming response that I want, Juliana. So, um, it is cause for concern. So, it means that I have to.
So I understand that concept,
No. Hold on, Logan.
but the
Hold on.
thing is that,
No, Logan, hold on. Hold
yes,
on. Press
yes,
pause.
yes,
Did I do this question in class with you?
yes,
Yes, sir.
I did?
yes,
Anybody else can agree that I did that question in class?
Yes, sir.
yes, sir.
Okay. And did I
And I
say to you that?
even able to do the homework that's similar to it, and I get it.
No, but hold on, Julian. Because you just tell me a while ago, 'cause I projected something I said to me that I never did. So I need to just clarify that.
No, it's the 2x squared plus 5x plus 3. And the way you project it is said that I need to focus on the middle one and on the constant that doesn't have any x. And then factorize the middle one, if you get what I'm saying.
I absolutely have not got more to say because I did not say that. Let's go. Let's
Huh?
go again, please.
Okay.
I want all of you to listen. Let's go again. Students, I'm not going to be able to do this. When I teach something, I expect it to be reinforced because I have a syllabus to finish and I try my very best to explain stuff. So when I teach you, I'm not going to have the time to go through this stuff again. I even remember saying to you that factorization is not on your syllabus. And I even went as far as saying to you, that's why the prerequisite for this course must be met. I remember what I talk about, and I have my recordings to support me. Students, when we come to class on a Tuesday and on a Friday, please ensure that you are ready for my sessions. You see, the next time I come to class, and I am ready and I'm hearing all of this shenanigans about, oh, sir, it's the first I've seen it. Oh, sir, no, I don't know. I am moving on. I understand that you guys work, but you have to set a time for your work, your schoolwork, that is. And I'm sure some of you want to open your math book. That's if you have one. Today, since Tuesday of this week, nothing was done. And you know yourselves. I don't have to ask you to raise hands because I don't want anybody to lie, and I'm teaching long time. It's unacceptable, though. Really is unacceptable. So I'm going to ask you to pay attention now. And I shall do this once more. So I gave it this indeterminate form, and I said to find the limit as x tends to 3 of x squared minus 5x plus 6 all over x minus 3. We had our conversations, and I asked you to tell me what do you think the term indeterminate means, and I got many and varied responses, I would say all of which I could work with. All right. And then I also said to you that we are now going to be using the algebraic approach, different from the intuitive approach. The intuitive approach is me incrementally moving from the left-hand side and getting closer and closer and closer and closer and closer to the limit and observing how the limit behaves. And then I'm going to the opposite side and I'm inching closer and closer and closer and closer to the limit. And then I'm going to observe what is happening. Now, if my observations for both left-hand side and right-hand side are equal, then the limit is of a good behavior. The limit exists, and whatsoever that value is approaching is going to be the limit of the function. Also said to you that whenever you're going to the exam and they say to you, evaluate the limit, do not apply the intuitive approach. Sir, why? You're not going to get the same answer? Absolutely. But that approach is longer. The best approach to use is the algebraic approach because, boom, one shot, your answer is out. So what the algebraic approach is saying to us is, we are going to assume that the variable x tending to 3, we are going to assume that x is equal to 3. Let me ask a question. Is x equals 3?
Yes, sir.
No, sir. We are assuming that it's 3.
Yeah.
We're assuming that it's 3, but what is x doing to the 3?
Tends to 3. Tends to 3.
It is tending to
Approaching
3 or
3.
it is approaching 3.
Right.
So x is not equal to 3. And if x were equal to 3, you wouldn't see this right-hand side arrow. What would have seen here?
Equal sign.
An equal sign.
Sir. Mm-hmm.
Right, an equal sign. So the mere fact that you're not seeing an equal sign, it is saying to you that it's not equal to 3. However, in applying the algebraic approach, I am going to assume that x is equal to 3. So therefore, wherever in the function I see x, I'm going to substitute 3. Wherever in the function I see x, I'm substituting 3. This is going to be x squared, it now becomes 3 squared, minus 5 times 3, plus 6. All over 3 minus 3. 3 squares are 9, minus 5 times 3 is 15, 9 minus 15 is negative 6, negative 6 plus 6 is equal to 0. And 3 minus 3 is equal to 0. Now, once it is that my function says 0 over 0, it says to me that my question is indeterminate. When I say that it is indeterminate, I'm saying to you that there is something inside the function preventing the true function from coming out. There is something inside that function preventing the true limit of the function from coming out. And even though I'm saying this again, I'm sure that when I give you some assessment, some student is going to be doing the very thing that I'm asking you not to do. If you say to me that 0 over 0 is equal to 0, sir, and the answer is 0, you are wrong. That 0 over 0 is not an answer to say that the answer is 0. It is a partial response to say to you, wow, sir, it is indeterminate. When it is indeterminate, I need to do three things in order to isolate that thing that is preventing the true limit from coming out. What three things do I need to perform?
Sir, rationalization, factorization, and I don't remember the third one.
Simplification. Thank you, Alway.
Simplification.
Right. So you're going to be doing a rationalization, a factorization, or a simplification. One of the three. I also said to you in class that the questions that we are going to be doing now will be questions on factorization because I have not yet done any simplification or have I done any rationalization with you. Does anybody remember that conversation we're having?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
All right, thanks. Because sometimes I wonder if I'm getting a little there and I need to just exit the classroom because I'm sure I said it. Then no. That 0 over 0 is not an answer to be equals to 0. It's an answer to say, yo, factorization, simplification, or a rationalization. Something must give so that I can isolate what is preventing a true limit from coming out. All right, no problem, sir. Got to that question. That was at the end of the page. Yes, it was. Got to that question, and then I said, you know what? I'm not here to teach you factorization. However, let me just recall. So the methodology is that you're going to be multiplying. Matter of fact, where I started was the coefficient means the number in front of. Coefficient means the number in front of. The coefficient of x squared is the number in front of x squared. The coefficient of x is the number in front of x. And the constant is that standalone term. As a matter of fact, what did I say to you that a variable is sitting right by that 6? You know what? Leave that one alone. Soon come. Again, press pause. I'll soon come to that one. So therefore, what I'm going to do is to multiply the coefficient of x squared, which is an imaginary one that is here. X is not equal to 1. We're just looking at the variable in front of the function, the variable, the term in front of the variable, that is. The variable is x in this question. And the coefficient of x squared is a number in front of x squared, which is a 1. What is the coefficient of x?
-5.
Good job. Thank you, sir. What is the constant term?
6.
Good job.
6.
Very nice. So the methodology is to multiply the coefficient of x squared by the constant. 1 multiplied by 6 is a positive 6. I need two numbers. When multiplied together will give me positive 6, but when added will give me a -5. What two numbers do you think we're referencing here?
-3 and -2.
Has to be. Those are the only two terms. I would call those terms factors in the whole world that could satisfy the condition of this question. Angle 2. So my factors are -3 and -2. So how you know those are the factors? Let us check. -3 times -2, when I multiply two negative numbers, I get a positive number. -3 times -2 is going to be equal to +6, don't?
Yes, sir.
Yes, sir.
And when I add -2 to -3, what do I get?
-5.
Bling, 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 bling. I found my factors. I found my factors. And then I have found my factors to be -2 and -3. And then I'm going to dismantle the middle term. I'm dismantling the middle term. Let me ask a question. Why do you think I am going to be dismantling that middle term into -3x? I had -5. Why am I dismantling that that middle term to -3 and -2?
So you can group them, sir.
So I can group them. All right. So couldn't I group them and I had 3 terms?
Yeah, but they wouldn't be split evenly.
Okay, very good, sir. See, that's the reason I had to break them up. So if I went ahead and grouped, I would have one term with 2 terms and the other one with 1. So that -5 had to be broken up into -3 and -2. 1 each to the first term and to the last term. Sir, does it make a difference which one I put down first? No. So I have -3x minus 2x. If you so desire, you could have put -2x minus 3x. It really doesn't matter. Okay. And then when I drop my parentheses inside the question, because I'm grouping to a piece, the middle sign must be left out. All the time. All the time. The middle sign is to be omitted every single time. And then I'm going to ask myself the question. What is common here between x squared and the -3x? And then the response is going to be positive x. What is left when I take out a x from this x squared is going to be x. What is left when I take out this x from this -3x is going to be -3. Can everybody see that?
Yes, sir.
Yes, sir.
Good job. And then I ask myself the question, what is common between 2x and -6? And hopefully your responses would be -2. And then I'm taking my -2 here. What do I multiply by -2 to give me -2x? It has to be an x. What do I multiply here in order to get this positive 6x? It has to be a -3. -2x times -3 is going to give me a positive 6. Besides all of that, what I just explained, whatsoever is in this parentheses has to be the same term in the nether parentheses. Then I ask the question once more. What is common here that is common there? And you should tell me, sir, x minus 3 is common. And then I ask you what is left. And it has to be -2x. 2x minus 3 is 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 x minus 3 times x minus 2. And then I'm going to substitute all of that, x minus 3 times x minus 2, for my x squared plus my x squared minus 5x plus 6, because that's what the question asks me. So my factorized term, I'm substituting up here. But sir, you're changing the question. No, I'm not. I'm not changing the question. What it is that I'm doing, I'm adding some flavor to the question. Similar to how when you cook your food. You add seasoning to the stuff, you don't eat the thyme, you don't eat the scallion, you don't eat the pimento, you don't eat the garlic. When the food cook, you take out what it is that you would have put in because it has done its purpose. This x squared minus 5x plus 6 would have done its purpose. I remove it. And then I recognize that there's an x minus 3 in the denominator. It has recognized its brother, and they decide, yo, let us go about our business. So what I'm left with is just x minus 2. And then it says the limit as x tends to 3. So anywhere in the function I see x, I'm substituting 3. Therefore, the limit as x tends to 2, 3, right? 3 of 3 minus 2, 3 minus 2 is 1. So the limit as x tends to 3 of 1, your answer is 1. Is that a little clearer now, guys?
Yes, sir. I saw the part that I made mistake of. I forgot to do the constant and the coefficient. I should time it to get the 6 and then to see if it match with the 5x, and then we can factorize it. I did not do that the first part, so I'm able to understand it now.
Did I give that question to do?
Hmm?
Did I give you that question to do?
This question.
Numero dos. I know the answer already, but I'm just checking.
Yes, sir. I think
Oh,
you
the
did
what? The first question that we attend to the class. Yeah, I was able to get 1, so I was able to understand all of that. So, yeah.
Alrighty. I gave you one for homework. What was the question again?
Hmm?
So that was number 4. X tends to negative 5. That question.
And then
How many of you did it?
I did it. The
I
answer
did.
is negative of.
Okay, go ahead for me, Taj.
So I just raised my hand to say I did the homework.
Yeah, what you got for the answer, Pops?
I got negative half, sir.
You got the negative half?
Yeah.
The same answer, sir.
Who's that? Who got the same answer? Lecarno?
Yes, sir.
Okay, good job, Papa.
Me too, sir.
Alwyn?
Negative 1 over
Okay,
2,
good,
sir.
good job, Alwyn. Nigeria, what you got? What you got?
Negative 1 over 2, sir.
Okay, that's the same thing as a half. But it's just 1 over 2. People are saying that get negative a half. What you get? Just so 1 over 2?
Negative, what's the negative first, sir?
Oh, me never hear you, Papa. You said the negative kind of silent. Me never did hear you.
Yeah, man.
Damoy, go ahead.
Are you telling everybody good or you're not telling me good, sir? And I was the first one to answer.
And you really stopped me for asking me that, Logan? Dujon, what you get for the answer?
Yeah, but
Well,
funny enough, sir
you say
said
you
good,
drive.
not say right, you know.
What you say?
No, man, tell her, say a while ago when they said good, that not say right.
Absolutely. Absolutely. What you get for your answer? Damoy, what you get for your answer? Ashanti, what you get for your answer?
Wait, sir. I got negative a half.
Okay, all right, thank you. Okay, Matthew, I see that. Okay, okay, I won't mind it because you know that it is atrocious, so I will leave it alone. All right, I'm just struggling you, Papa. Evan, Mr. Liston, sir, what say you? Evan, what you doing? Evan.
Sir, evening, sir. Me never did the last class.
You did a course with me in the summer, don't?
Yes, sir.
Oh, okay, because I'm saying to myself, you're not supposed to be in this group. But anyhow, yeah, just remember. You weren't here the last class. You see, all of
No,
matter of
sir.
fact, it's all right.
I missed it.
I'm going to fix up my class over this weekend here, so we will have Damoy, I asked you a question and you have not responded. Have you, Damoy? Damoy, have you responded to me, Damoy? Okay.
Sir, what do you mean when you say I'll fix up the class for a weekend,
Sorry.
sir?
Sir, can you hear me?
I can hear
Sir,
you now,
it's
sir.
Damoy.
Yeah, I can hear you
Oh,
now.
sorry, sir. I literally just came home.
Because
I
I
got a
was calling you
negative
before. That's why
answer.
I called you so strong a while ago because I was calling you before and you weren't
Oh,
answering me.
oh, sorry, sir. Sorry, sir.
Cool. Justin, what say you? What do you offer the answer?
So I got 1/-2.
You got 1/-2. All right. Thais, what do you got? Sir, can I repeat that? I was asking Thais what you got for the answer.
-1/2.
-1/2? Oh, okay. Finally, Romain, what you get? Romain, what you got for your answer?
Sir?
Who is calling me?
Kaim.
Yes, Kahim, what's up?
Sir, did you call me or?
No, I said Romain. I called him like about 3 times, and
Oh.
normally when I call students, I don't respond to me. I just put them in the waiting room, because they can't be in a class and the teacher calling upon you, you're not responding. So if you're not in a position to speak, let me know from beforehand. All right, Matthew, I won't call upon you because I saw your response. Kyle, I think I saw your response just now, so I won't call. Chrisan, I am not seeing a response from you. What did you get for the answer?
1/-2.
Okay. Chrisan, tell me the difference between 1/-2, -1/2, or just -1/2.
Yeah, I'm not too sure, sir, because what I
Not-
had done when I had finished substituting in X, I had gotten 1/-5 + 3, and then it equaled out to 1/-2. So I wasn't too sure if it made a difference. So I put both answers there. So I finished the answer by saying 1/-2, and then I put the 3 dots to say answer equal -1/2.
Okay. All right. So the more I put in the chat to everybody, I'm seeing some private responses, but I
Sir,
won't talk about the private responses. Go ahead.
So I think there's a difference. I don't really know how to explain it, but you know how
You think there's a difference? All right. Try, Kahim, let me hear you.
when you have like when you get the value after you factor the denominator, I think only the denominator is supposed to be negative because it was -5 + 3, and that's under 1. So I think it's important to have just the numerator as a negative value, if that makes sense. I don't know how to explain it, but
Never mind, Kahim. I like the
I have a
effort.
question.
I'll come in, Chrissy. Just 1 minute. Kahim, I need to extend a conversation. So let me see who said it. to everybody. Okay, so Damoy says his answer is -1 over +2. So Kahim, you're saying that Damoy is incorrect?
Well, if I'm correct, then he's incorrect.
Okay, if you are correct, then he's incorrect. Christian, go ahead. Let me hear your question, please.
Because the reason why I ended up putting -1 over half again, is because when I plugged this into the calculator to see if it can go break down any further, I plugged in 1 over -2, and the calculator showed me -1/2. So I put it there just in case. Because even though I had 1 over -5 plus 3, and I left it at that, when I put it in the calculator to see if it could break it down further, it just gave me -1/2.
Okay.
Sir?
Yes, Danger.
I'm not sure if Kahim did hit the ball out the park, but the same answer that he says that he has, right? I have. Because what I did was factorize the denominator, which gave me -5 plus 3, which is 1 over -5 plus 3, which is 1 over -2 as the answer.
Yeah, man. So he said that, but Nigeria,
Right.
my question to you is,
if there's a difference.
Damoy gave me in the answer, well, gave all of us in the answer. I won't call out what the rest of the students sent to me privately as I'm looking at them now. But Damoy put in to everyone -1 over 2. I'm seeing where Ashanti is saying, boy, sir, I basically the same thing, but so are you saying then, okay, so Kahim says, well, sir, if I know I am right, that and we don't have the same answer, that means he is wrong. I'm asking you now, Nigel, do you support the point that you are right, and if you are right, that Damoy is wrong?
Yes, sir.
So Damoy is wrong. All right. Have you ever met anyone, Nigel, who has the last name Mason?
Yes, sir.
You have. Where was this? In school or work?
Work.
Work. What if I come in the office and say, Mason, what will happen?
Well, we're gonna look up.
So I'm not gonna look up. And I'm assuming that the person, the other Mason, is not an N. Would that be correct?
What do you mean it's not an N?
The first name.
Oh, no.
All right. But if I come into the office now and say,
Nigel.
N Mason,
Oh,
you know who I'm talking to, don't?
yes, sir.
What if I say, Nigel, you know who I'm talking to, don't?
Yes, sir.
All right, good. Kahim.
Yes, sir.
Do you know that when I have me a fraction like 1 over 2, that the numerator and the denominator are married? They're inseparable? You figure that one out?
Sir,
Yes, please.
could I make a point about
Go
the
ahead.
negative number?
Go ahead.
I'm saying that just like how we have rules that if we multiply a negative number by a positive number, we get back a negative. So I'm saying that since it is a fraction, but we're dividing, so it's 1 by -2. So by right, the whole thing should be negative.
Okay.
At least that's what I think, sir.
All right. Thank you for that, Juliana. So what I'm saying to you is, if you have -1 over 2, the mere fact that the numerator is negative also makes the denominator negative. If you have 1 over -2, the mere fact that the denominator is negative, that negative sign controls a whole fraction. So if I say 1 over -2, it is going to be the exact same thing as if I were to say -1 over +2, or it will be the exact thing if I say -1 over 2. -1 over 2.
So, sir, would it be different than saying -1 over -2?
Aha.
Yes, sir.
Hold up. Juliana,
Yes,
would
sir.
it be the same thing if I said -1 over -2?
-1 over -2.
Mm-hmm.
No, it'd be different.
It will be different? Anybody,
I
somebody?
mean, I'm going to look up the rules.
No. Based on what you just said a while ago, don't look up any rules.
Or, all right,
somebody,
sir?
go ahead.
No, sir, it would be positive. The signs would have cancelled out each other.
Easy 1, 2,
That's
3.
true. When you put it into calculator, it cancels it out over half.
Sir, excuse
Easy
me.
1,
So
2,
it's like the
Just
same
Let
with the
us bring up the
multiplication
calculator.
then.
Yeah, man, because you divide two negative numbers, it will become a positive number. Right? So just remember, I thought about the question because of how it is that I'm getting the responses in the chat. Some of the responses you're not seeing because some of them are direct messages. But yes, so if I have two negative, and besides, if you had two negative numbers up there, it would be wrong because the numerator really wasn't negative when it evaluated. Because the numerator would have been a positive number. Would be just 1. True or false?
True.
Yeah. So there's no way the numerator could be negative. So look at what we have. So you guys learned something tonight. It says x as it tends to -5. So therefore, anywhere in the function I see x, I put -5. -5 plus 5, -5 squares plus 8 times -5 plus 15. -5 plus 5 is equal to 0. -5 squares is 25. 8 times 5 is 40. 25 minus 40 is -15. -15 plus 15 is 0. Boom. That 0 over 0 says to me that it is indeterminate. It doesn't say to me that the answer to the function is 0. It says to me that, yo, sir, I have something that is indeterminate. It means that as it is just now, I cannot determine the actual answer. There is something that is preventing the true answer from coming out in the limit. So therefore, I must do a simple operation in order to isolate that which causes the true limit from coming out. A simplification, a rationalization, or a factorization. So we're going to do a factorization. And when we factorize, we are multiplying the coefficient of x squared by the constant. 1 times 15 is 15. I need two numbers. When multiplied together will give me 15, but when added will give me an 8. 5 times 3 is 15, and 5 plus 3 is 8. Do you agree with me?
Yes, sir.
Yes, sir.
Good. So I'm going to have x plus 5 times x plus 3. So what I'm going to do, I'm going to resubstitute my x squared plus 8x plus 15 for x plus 5 times x plus 3. Boom. And then I recognize x plus 5 and x plus 5 can be cancelled. Now, whoever asks a question, if I could have -1/2 over -1 over -2, there is no way the numerator could be negative. It is so 1. So 1. I can't substitute
That's
nothing.
exactly what I was thinking.
Yeah, man, I want so 1. So 1. But the one I don't hear so no. When you substitute the -5, -5 plus 3 is -2. Right? So you can have 1 over -2. You see what happened here? 1 over -2. But when I'm rewriting my answer, the whole function or the answer itself becomes negative.
So,
Let me
sir,
answer. Go ahead.
would you say it's a good practice that after, like what I did, after I got the answer, I put it into the calculator to see if we can go down further?
You know what is a good practice, Chrissy? For you to buy a natural display calculator that you can just bring something in a calculator and it
tells
spews out
you.
your answer. Yeah. If I were to teach you calculus too, it's going to be very important that you have a good, decent working calculator. Let me ask you one other question, just to sum up this one, because I'm going to move into another question, the one that I give for homework. Anybody ever get one eyelash in their eye before?
Yes, sir.
What happened to
It's
you?
uncomfortable.
Just
Your
that?
eye
Rub my
red,
eyes.
your eye red, your eyes start to water, you can't even open your eyes properly, it's itch.
No, man.
Feel
No, no,
like you're
no,
being blind.
no. Your no eyelash can't go in your eye. Somebody tell me what happened to them when your eyelash get in your eye, please. Nobody had not hurt them.
Okay, take it out.
We say?
It's very uncomfortable.
So you try
Nobody
to
have a
so it, I
migraine.
guess.
So when they just take it out.
So your
You
eyes
just take
get
it
red.
to.
The
All
eye
right.
tears up and it tries to push it out.
And
All
use
right.
water
Good.
and wash it out.
I use water and wash it out. All right. At the same something. So when a negative sign going in your eye, it will change everything. So everything about you is uncomfortable, as Logan said. You feel uncomfortable. This negative sign is very controlling. When you see a negative number, have respect for it from it, please. Real talk. When you see the negative sign, call it Mr. Negative. Don't play with it. Don't play with it. Your order of operations must be of such that you know how to deal with your negative numbers. Don't play with it, because there are going to be some functions that I give you that are going to be negative. And you know what the man them love to do? The man them knows that students have a problem with negative signs, so them love set questions with negative signs. So you have to develop a love affair with it, yeah? All right. Now, with that said, that was a good
I
that was a
fixed the
good
problem. I was putting
Review.
it into my calculator wrong. I was breaking
okay.
up the question. I didn't put everything as a whole for it to solve.
Yeah, but what I want you to still do for me, Chrissy, is to get a natural display calculator.
I have when it was the class and you said I went out and I bought a Casio
Nice.
FX A2M3.
Nice. That should work.
Sir,
So yes, go ahead, please. Oh, there's a question I need to ask. Yes, Damoy.
oh, sir, remember, says me did have the original problem with the calculator, sir. Sir, the Casio FX 82EX, all right?
Yeah, man. Are you the other Kenko?
Yes, sir. Me have the Kenko. Me have a
Where do we do
Casio now.
Where do we the Kenko?
Sir, me still have it.
No, man. If you dash it away.
No, me have a Casio now, sir.
Okay, all right. Park it though. Put it far so you can't see it, right? There's a question there's a question I need to ask before we move into question 6. I need to ask you some more questions. I need to see if you are really following what is happening, because sometimes I believe when I come class and then I just gone, left the device, and don't pay me no mind. Look at that question. Can you tell me what was preventing the true limit of the function to come out, please? What was preventing the true limit of the function from coming out?
So is it that the +5 was cancelling out the -5?
Return. Which negative
Or you
5?
get 0?
No, man, don't mute that, man, Papa. Come on, talk to me. Which negative 5 are you talking about, Pops?
Sir, the limit that it was approaching. So x was approaching -5, but and the equation had a +5.
All right. So one, there's no equation, but you see the thing about it. Did I substitute the limit in here so yet? Return? So no.
Oh well, no.
All right. Good. So
There you
that negates your answer then. Let me ask the question one more time, and I don't want to give it away. I just want to see if you guys are thinking. So what do you believe is preventing the true limit from coming out right here?
X plus 5, sir.
The x plus 5? Why you say that though, Reggie?
I said that, sir, because we needed to cancel it out. We needed to get it out of the function in order for the in
True
order for
limit?
the limit to come out, sir.
All right. Very good, Reggie. Do you agree that it's the same thing here that was happening? What was preventing the true limit from coming out here?
It's -3, sir.
X minus 3. The rest of you agree?
Yes, sir.
Yeah,
Yes,
right.
sir.
Good. Because as Rajay says, we got the function to be indeterminate. We got the function to be indeterminate. But as soon as we use a simple calculation, we were able to cancel out that which prevented the true limit from coming out. So once I isolated what is prevented the true limit from coming out, then I am able to tell you the true limit of the function. So that's very good, Rajay. And I hope that the rest of you would have seen what we're talking about. All right. So the warm-up question, you recognize the x plus 1, the x minus 1 was really preventing the true limit from coming out. When those two cancel out, I'm going to be left with 2x plus 3. When x is, assuming that x is equals to -1, 2 times -1 is -2. -2 plus 3 is going to be equals to +1. Is the topic getting a little clearer to you guys?
Yes, sir.
Yes, sir.
Okay. I have one final question before I give you another question.
Sir, before you move on, though, I think I see a pattern of some sort. So is it that for the part of the fraction that will cancel out, it would be the opposite of the limit, if you understand what I'm saying?
Does that answer your question, Riton?
Yes, sir.
Tell me how it answers it.
Because x plus 1 has nothing to do with 4.
Okay, thank you. All right. That's what teaching is, you know. You give examples and then you see things and then we try other ways, and then this is how theorems come about. So a theorem is something that has been proven that every time you do something, this is what you're going to be getting. So this could not be a theorem because it fell through right here. So this one here is not the opposite of this. So that statement can't be true. But I have one other question, though. Final question. Final question. Should I ask it? No. No, I'm not going to ask it yet, but let me see how well they do work on this one. Number 6, quick and fast. Give it 3 minutes for number 6. 3 minutes for number 6. Quick and fast, please.
Answer is 1.
Good one, sir.
Okay. Juliano, how we
Yes,
stay?
sir.
How we stay?
Still working, sir.
No, I know you're still working, but I'm asking you, how are you with the factorization now?
Better, sir. Understand
Okay.
it better.
All right, good job.
Yes, sir.
Is there anybody still struggling with the factorization? Okay.
Me, sir, I feel like I need more practice. Sometimes I get it, sometimes like I don't get it same. So more practice needed.
Okay.
So I'm gonna tell you straight. We think we still not understand my calculator.
Which one you have, sir?
The Casio 300 ES.
I'm a good calculator, that one. That's the blue and white one on the front part?
Straight black.
With
The
the
only
trap, with the trap.
difference with the next one is it have the solar. I think
Yeah,
somebody
man.
else have
Good,
another
good,
class.
good, good calculator, that man. That is better than the FX82. That is the 300 ES. That you said it's 300 ES you have?
Yes, sir.
Right. That's the upgrade to the FX82. So it's better than the FX82. All right, work with me now. Do you see how we look now? Do you see a box sitting on top of another box in the top key? Could be in the second row or the third row.
Yes, sir.
Or,
That's
right,
what I.
you see that?
Yes, sir.
All right,
That a
that's your division,
fraction.
but that's a
Right.
fraction, but yeah, that's a fraction, but yeah, that's a fraction button. So you need to be familiar with how it is that you need to work with your fractions. Makes life so much easier.
And that alone are the problem, you know, sir. I have that part that lack.
Mhm.
Suppose my work all of the numerator across.
Mm-hmm.
And man, this is the struggle starts, sir.
Yeah, you can work it. You can work it. If I can remember, well, I had a calculator like that, and I had a student, a math student who was up there, very good math student, and I willed it to the math student, a live will to the math student because of how proud the student performed. But if I remember that calculator that I had, you could also work out a differential and an integral on it. So it will be very useful for this course, because you're going to learn differential and integral in this course. So you could actually use it to double check your answer. It won't give it a step by step, but if you do the question, you can put the information in the calculator to tell you whether or not you're right or wrong. So you do have questions for 5 marks, for argument's sake, and you get your answer, and you put the information in the calculator, and you get the same answer. You know, sister, I can give you 5 marks because you'd have shown me your methodology. So it means that you'd have had everything right. So that's a good calculator to get, as a matter of fact. That's the one I promote, the FX300. All right, answer.
One, sir, whatever.
One.
Everybody got one?
Yes, sir.
What was preventing the true limit from coming out?
X plus 3.
All right, thank you, Ashanti. You are correct, and I'm telling you you're correct up front because I want to ask another question. Why was X plus 3 the problem? All of you look at the question. Ashanti is going to answer. If she gives the right answer, with whatever answer she gives, I'm going to ask the class if she's correct. And if somebody says yes, I'll move on. But if somebody says no, you're going to tell me why it is that you disagree with her. Ashanti, this is a question to you. So I would agree with you that X plus 3 was that which was causing the problem. Why was X plus 3 causing the problem? Because?
All right. It made the denominator 0.
Excellent. Moving on. Everybody agree with that?
Yes, sir.
Okay.
Yes, sir.
Very good. So when X is equal to -3, this becomes -3 plus 3. Can I have a 0 existing in the denominator?
No, sir.
No.
Sir.
Cannot have a 0 existing in the denominator. So that was what was causing the problem. What was causing the problem was the x plus 1. Because when I substitute -1 into the function, it's -1 plus 1 is 0. That was causing the problem. Why? Because I cannot have a 0 existing in the denominator. Uh-oh. You wouldn't know what is happening here. Yes, sir, I would. Because there is something inside of this function. You're not seeing it exactly, but there is something inside of this that is going to cause the function to be equals to 0. Can you guesstimate inside of this x squared plus without? All right. What do you think is causing the problem in this denominator here? What do you think was causing the problem?
X plus 5.
The x plus 5, because inside of here is one of them something here that I need to get out, because that is what is causing a problem. Why is the x plus 5 causing a problem? Because
The denominator.
because
Denominator equal to 0.
The numerator, sir.
The numerator, sir.
No, because
The denominator equal to 0.
no, because
The numerator.
no, because
Is a positive number.
finish your thought. Because what?
Because the equation cannot have 0.
No.
Sir, x minus 5 plus
Because
will be a 0.
As the numerator can't be 0, sir.
All right, hold on.
because the limit is -5, sir.
Yeah, but somebody was saying something before. Oh goodness, I don't catch your voices yet, you know, that's a problem. Somebody.
5 is a positive. Yeah.
Okay, I think it was you, Damoy, was saying it. Yes, because the limit is going to -5, and there is a positive 5 there. So what it is that we're doing, we're adding opposites. So anywhere you see the opposites being added, you can always almost say that that is what is going to happen, right? I know you guys may not like tonight's class because I'm asking a lot of questions, but that's fine.
That's what we learn.
I have to make sure say you understand the stuff. So whatever examples I have to give you, correlation and questioning, I have to do it. And I hope you guys are understanding better. All right, good to go. I'm feeling a little happy that you understand the stuff. Yes, the answer is 1. The answer is 1. Oh goodness, I can't find my stuff. All right. All right, let me ask a question, please. I need to go and look and see if I can find my pen again because I want to write something. Tell me. Tell me. Do you anybody has any past papers with them? Anybody start downloading past papers from the system?
Sir, which system?
The library.
Oh no, not yet, sir.
All right, thank you, sir. All right, so I'm going to move into a new type just now. I'm going to need your undivided, please. I'm going to need your undivided. I'm going to need your undivided. Now, hear me out. You see, if you want to be, you see, if you're driving and it is safe for you to pull off and watch what I'm doing now. Because you miss this, you're going to have problems. All right. Are you see my screen that says indeterminate form, positive infinity?
Yes, sir.
Yes, sir.
Watch me carefully. You only need to say this once. So you may get a question like this to say the limit as x tends to infinity. This is not a lay down 8. It is called an infinity sign. It's an infinity sign. It says the limit as x tends to infinity of x to the 4th minus x squared plus 7 over x to the 4th, sorry, 2x to the 4th minus 6x squared plus 3. And it is asking us to evaluate that limit. then sir, I'm not going to evaluate the limit because they say no, I forgot use. We can use 1,000, sir? No. Remember, I asked a question. Somebody asked a question last class, and I said, let us use, oh Lord, what was it, guys? 100, 1,000, million? I think it was a million that we used. And we worked the answer out and we got 1 for the answer. Anybody remember that, please?
Yes, sir.
Okay, good. So I don't have to find it. Great. So we got 1 million for the answer. I mean, not 1 million. I think we got 1 for the answer. But I did say to you that whenever I come to this point, we're not going to be using that methodology to work it. I want you to pay attention. Watch me. So if and this here now is going to be abstract. So in mathematics, we have some things that we call abstract and some we call concrete. Concrete is when I can show you 2 things. So you have a concept of what 2 looks like. I can show you 2 mangoes. I can say this is 1 mango and this is another mango. That's concrete. You're seeing it. You can count it. But if I say let this represent X, you have to imagine what X is. You don't know what it is. So in math, we have something that we call something that is abstract and something that is concrete. No, concrete is hard evidence. You can see it. It's right. That's why it's called concrete. Hard evidence. The other one is going to be very abstract. And here it is that I'm going to introduce some abstract stuff for you. Watch me. So if I think of X, if I think of, X being an infinitely large number, infinity raised to the 4th power, what do you think that is going to be?
Infinity, sir.
Infinity. Excellent. Excellent response.
Repeat, sir.
Infinity raised to the 4th power. What is that going to be?
Infinity times itself. Infinity to the 4th power.
Yeah. So what are we going to get? We're going to get a smaller infinity or a bigger infinity?
Bigger infinity, sir. Bigger infinity.
A big infinity, don't? All right. I like the thinking. I like the thinking. No, watch me. Infinity squares. What is that?
Infinity times infinity.
Same infinity, sir.
Yeah, but it's a big infinity to don't.
Still a big infinity, yes.
Is it as big as the x to the 4th?
No, sir.
So if I said to you x to the 4th, infinity to the 4th minus infinity squares, is this still a big infinity number?
Yes, sir.
Sir, yeah, subtract from it.
Huh?
Yeah, subtract from the infinity, sir.
Yeah, man, watch me. So if I have infinity to the 4th power minus infinity to the square power, when I subtract infinity to the square power from this, do I still have a big infinity?
Yes, sir.
Good. And if I add 7 to it, it will increase it by 7, don't?
Yes, sir.
All right. So can you agree that the numerator is going to be infinity?
Yes, sir.
Everybody see that concept, that reasoning?
Yeah. Yes, sir.
Yes, sir.
Is there anybody in the class that don't see the reasoning?
Go on again, sir.
All right, watch me, Latano. Watch me. Infinite, and guess what? I don't want anybody to put in any figures or values in something and say, all right, so we're gonna try 1,000. No, I want you to be able now to develop your abstract level of thinking. Work with me, Lacarno. Infinity to the 4th power is a larger infinity than what we started off with. True or false, Lacarno?
True, sir.
Yeah, true. Kyle, what you say?
Yes, sir. Good one. What will I watch?
All right. Good. And then now, when I subtract the infinity squared, do you agree that I still have an infinitely large number up here?
Yes, sir.
Good. That's kind of how you stay.
Yes, sir. I'm good, sir.
Yeah, man. No, me no want you mute the kind because you ask me a question, I'm want you able to answer in a real time.
All right.
So when I have that infinity Lacarno and plus it to a 7, it's still large, a large number, don't?
Yes, sir.
Good. So you understand this infinity right here, so right, Papa?
Yes, sir.
All right, work with me still enough. Infinity to the 4th power. Sir, that is a large infinity. Times 2. It's a larger infinity. Whoa. But watch me. Infinity cube times 6. I'm going to have this larger infinity minus 6 times infinity, a big infinity. Is this an infinitely large number still?
Yes, sir.
Very good. It is. I'm going to add 2 to it. It makes it even larger by 2, don't?
Yes, sir.
Yes,
This is
sir.
infinity. Can you see that abstract now why I have infinity over infinity?
Yes, sir.
All right. Good job. I am teaching way too long.
You will never substitute anything,
No,
sir.
sir. I don't want. You notice that I never substitute anything right here, sir?
Yes, sir.
And anybody me catch I do no substitution, I will mark up in a paper because I don't want you to do that. I'm developing your abstract level of thinking. Work with me now. I'm teaching way too long to be fooled that what I just went through a while ago, that everybody understand it. Way too long.
Sir, I'm just running back the class. My light had went away.
Oh no, hush. Is there someone in the class that's not seeing something and want me to go through it again? All right.
So, well, for the denominator, so we have 2x and 2x raised to the fourth minus 6x raised to the cube. How is it that you know that the value that comes out, we know that it's an infinitely large number, but how do you know that the value that will come out of 6x to the cube is going to be smaller than the one before it?
All right. Okay, nobody respond to him for me, please. I'm going to ask him to respond to his own question. Rayton, look at what is happening here. Look at it, look at the terms, Rayton, and tell me how you think. I'm going to give you an opportunity, Rayton. I don't want anybody to help him. Look at this, Rayton, and tell me if you can answer your own question.
Is it that we're just looking at the exponents?
Well, that's a good way to start. Which of the term has a larger exponent?
Well, the 2x.
Good. So therefore, 2x to the fourth is going to be a larger number than the 6x to the third. True or false?
It would appear that it would be true.
No. Don't tell me up here. Rayton, if I say to you that this term, the variables are the same, x and x. It's the same x.
Right.
It's not like I'm talking about a US dollar versus a pound sterling. That's not the conversation. It is going to be pound sterling, or US dollar, US dollar. It's the same variable that we're talking about. So right there and then we'll have a level playing field. You follow me? Now, if this is x to the fourth and this is x to the third, which of the two you think is larger?
X to the fourth, sir.
No.
Well, I think the issue I have is when you come now and multiply it by the coefficient of x.
So
it's
x to the third is a smaller number, even when you raise this infinitely large number to the third power. Put it this way, Rayton. I know you say you don't like examples, but I mean, examples are the only way we can learn stuff. And it's a pity I don't have my pen to show you. When COVID came, and you have 2 people in a room, and 1 person sneezed, how many people in the room will likely have COVID?
How many persons are in the room for? 2?
2 persons in a room.
1 person sneezes. So
One person sneezed.
That both persons now have COVID.
It's possible that both persons have COVID. And then each of those in the room went to their respective dwelling with 5 people in each in it. What happened?
Means that
what is likely to happen?
10 people plus those initial 2.
All right, good. So 12 people now, don't?
Yes, sir.
And each member of both families go to work with 10 people each. Family A will pass on to how many people?
Family A has 10 people, so it's Wait, I think you lost me, sir. So go back up a level.
I think you'd have seen what I'm talking about again already.
Yes, well, I get the concept.
It is moving exponentially. You understand that term when I say exponentially? See the exponent here now. X to the fourth is an exponent. And x to the third is an exponent. So when one person sneezes in a room of 2 people, and both persons go to them individual place and them have 5 people each, a 5 more plus 2 initially. It starts up with 1 person with COVID. It gone to 12. In literally like 1 hour, it gone to 12. And then each of those 5 people now go check them brethren or sistering. A household of people put 10 people. It's going to be 10 times 5, 50. So it's 50 plus 12 is 62. And each of those go to somebody else and to somebody else. It is the rate of COVID now was spreading exponentially. Anybody ever hear them say it is spreading exponentially?
Yes, sir.
Yes, sir.
And that they mean. So I say this to say to you, when I move x to the fourth exponentially is moving much faster than x to the third. I have an example below this to explain what is happening here. And for this example, I'm going to give you a little bit of numbers to work with so that I can concretize it this one time. But I promise you that I'm not going to go through that again. So now, having recognized that we have infinity over infinity, this is what we're going to do. We're going to look through the function, both numerator and denominator, and we're going to be looking for the highest exponent in the function. The highest exponent in the function. Look at the numerator and the denominator here in this question and tell me what is the highest exponent.
4, sir.
4.
4. Excellent. So that means in the numerator, the highest exponent is x to the fourth. In the denominator, the highest exponent is x to the fourth. Let me just caution you right here and say that sometimes the highest exponent does not occur in both numerator and denominator. Sometimes the highest exponent occurs either in the numerator alone or in the denominator alone. So it can happen in numerator alone, it can happen in denominator alone, or it can happen in both numerator and denominator. All right? Now, this is where we are. In this here case, it is in both numerator and denominator. It's both numerator and denominator. I am going to divide throughout the function by the term with the highest coefficient, which is x to the fourth. Talk truth. Is that term x to the fourth?
Yes, sir.
Good.
Yes, sir.
So each term, go ahead.
I have a question before we move on. So like how the numerator of x to the fourth power, which is the highest exponential in the numerator. So if the denominator did have x to the 5, x to the 5 would have divided by at the bottom.
Alvin, I hear your question, but answer me this, Alvin. What did I say you're going to divide? Tell me what I said you're going to do. I'm going to ask you to answer your own question again. Tell me what I said. What's the first thing you're going to look for when you get a question like this, going to infinity?
Yeah, yes,
you're going to? Very good. You're going to look for the term with the?
Repeat.
Say it again. You're going to look for the term with the what?
Highest exponential.
The highest exponent. Good. And then what are you going to do with that?
Throughout the divide.
Very good. So I guess you answer your question. So if the highest one was in the denominator, say you had an x to the 5 as you said, would be therefore divided by x to the 4th?
No, sir.
What are you going to divide by, Alwyn?
X to the fifth.
Absolutely. X to the fifth. All right. So
Right.
I know you guys know the answer, you know. So that's why I'm not going to, don't think that I'm going to be a repository of information. I'm only here to help you out, right? And to get the best out of you. So yes, Alwyn, you are going to be divided by x to the fifth. Had it been that I had an x to the fifth in the denominator. All right. So here now, I'm going to divide here by x to the fourth every term. This x to the fourth going to be divided by x to the fourth. This x squared is going to be divided by x to the fourth. The 7 is by x to the fourth. The x to the fourth by x to the fourth. 6x cubed by x to the fourth. 2 by x to the fourth. You show this, you get a mark. You don't show this, you lose a mark. The next step is for me to reduce the fractions. Watch me. X to the fourth cancels x to the fourth one time. One time. Don't be like whoever it was when them cancel something, or me know who. You cancel something and you just left off the one. X to the fourth into x to the fourth one time. Watch me. X to the second power divided by x to the fourth power. When I'm dividing and the bases are the same, I subtract my powers or my exponents. X to the third, sorry, x to the second power divided by x to the fourth power. What I really have is x squared. And x to the fourth power is really x squared times x squared. And if that cancels, I'm just going to have 1 over x squared. All right? So this is what is going to happen. I'm going to subtract the powers. That's what it is technically that I'm doing. I'm subtracting the powers. So what is going to happen is x squared over x to the fourth. All of this can go into this and leave x squared times. Can you see that?
Yes,
So I'm
sir.
going to have, good. I'm going to have 1 over x squared. See, right here, so I do it, you know. I do it right here, so for you. This x squared up here, so is this. And this x to the fourth here, so is me writing it as x squared times x squared. Because x squared times x squared is x to the fourth, don't it?
Yes, sir.
Yes, it is.
Come on, discrete math and algebra is. So when all of this cancel all of that, I just going to have 1 over x squared right here, so see here, so 1 over x squared. Can I cancel anything right here, so?
No, sir.
No, we carry it back. X to the fourth divided by x to the fourth goes 1 time down. And 1 times
Yes,
2 is
sir.
2. Come on, so I'm just put the 2 right here, so. And then 6x to the third over x to the fourth. The x cube going to x to the fourth and just leave 1x. So we're going to have minus 6 over x. You see that right here, sir?
Yes, sir.
Can I cancel anything right here, sir?
No, sir.
I'll put it back. All right. I want you to exhale properly because I'm going to put a sentence on the board. And this is going to separate the boys from the men and the girls from the ladies. But after I explain it, everybody will be men and ladies. All right? If you don't see the first time, it's not a problem. By the time I explain it, you guys will see it. I said, as x tends to infinity, as x tends to infinity, I am saying to you that negative 1 over x squared, I'm saying to you that 7 over x to the fourth, I'm saying to you that this term 6 over x, and I'm saying to you that 2 over x to the fourth will all go to 0. Tell me why do you think that they will all go to 0?
It's indeterminate.
Remember, you know, we check indeterminate from up here, say no. We know say indeterminate from up here, say no. So because we know says indeterminate up here, say no, we are doing something now. We are doing one of those operations that I tell you about the factorization, the simplification, and the rationalization.
Sorry, can you go down my look on it again? Look, me no know, I'm just a guess right here. So 1 plus 7 equal 8, 6 plus 2 equal 8.
Okay.
Probably when I cancel them out, they will equal to 0.
Okay. Everyone, let me ask you a question. I gave you £5 and somebody else gave you $5 US. Do you have 10 Jamaican dollars?
No, sir.
Why not? Of course. 5 plus 5 not 10.
Yeah, but hold on, US dollar you get £5. US dollar and £5 are two different currencies that and Jamaican dollar can't compare.
Oh, they're two different currencies.
Yeah.
So all you have to tell me, so we must add x squared and x to the fourth and x and get 1 plus 7 plus 6 plus 2 and see them cancel out, Papa. Are different currencies this?
I don't guess. Oh.
You see me I say?
Yeah, look up here, so that's why.
No man, don't look up there, so look down there, so man. Right?
Okay.
So they are different currencies. Or you can look right up there, so too. 1 over x squared, 7 over x to the fourth, 6 over x, and 2 over x to the fourth. Different currencies. Different currencies. Me can't have $5 and £5 and say me have $10. Crazy? 10 Jamaican dollar? Yeah, bad. You better come and go Western Union and go change out that. And we can go buy a little oxtail eat. Right? Go ahead for me, please, Justin.
I was asking if it will become insignificant if they change out the x's to the infinity. The values compared to the infinity will become insignificant.
What do you mean by insignificant?
This is sir?
What do you mean by insignificant?
Because infinity is infinitely larger than any value.
Okay, careful now, you know. Your first statement was correct. I'm only extending the question to see if you really understand what it is that you're saying, but I don't like how you start off with the response with the second part. So I'm going to caution you to be careful. I'm only asking you the question to see if you fully understand, because I think I know what it is. I think I know what it is. So let me ask you, how do you know that it becomes insignificant? Think about it. Your first statement was correct. I never like we start the second statement. How do you know that it's insignificant? What is insignificant? Talk to me now.
It loses its value.
What loses its value? What value loses?
The one that is assigned.
What value? Talk to me now, man. And is one class in his head right? Nobody can laugh, because nobody not answer me. Are you alone? So come talk to me, man. What value did it lose?
Sir, I'm not sure, but the values them have currently.
It loses the infinity value, sir,
Why?
because it will go to 0.
Oh, so that's the insignificant that Justin was talking about.
Yes, sir.
Okay. You see that now, Justin? You are giving me half say it again, Alwyn.
Oh, it loses the infinity value. That's why it goes to 0. So that's the insignificancy we're talking about.
All right, Alvin, I'm going to ask you the question now. Since the rest of them not talking to me and we're having a nice conversation, let us extend the conversation. Why is it moving to 0, Alvin? What is happening? Tell me the movements that are taking place. Why it goes to 0.
Sir, is it that you're dividing a
It's decreasing,
no
sir.
number by a very large number?
I like how that sound, but you can make it sound a little nicer. You want little, you have the oxtail, you want little choreography upon that now.
Which are the responses, sir?
Oh, no one response to give me.
Oh, I thought you were talking to Alwin. Oh, so you're dividing I wouldn't say constant.
Ah, that's what I
But
want you to say. That's what I want you to say. So say it now.
or you're dividing a constant by infinity.
And what happens to a constant?
When you divide,
Don't punish something the man and talk to me. What happened to the constant? Look at the function. Tell me what happened to the constant.
Is it the more you divide the constant, the more it reduces, sir?
No, that's not what I'm looking for. So I was looking for the word constant, but what happens to a constant?
All right, sir. Let me ask you, when you divide by a greater exponent, it decreases.
Yeah, we get that, Alwyn, but what happens? Okay, I was asking a question. Why does it decrease, Alwyn? Talk to me. Oh, Jesus. Oh, no, nasty to something, man. Dijon, talk to me. Demoy, come, you unmute. Come talk to me, Demoy. Let me answer a question. I'm sorry. Last week when I said I don't like my examples, but they work. I'm going to ask this example. If you don't understand it, then I'm going to continue. If you don't understand it after that, I don't ask some more of those examples. I have a bank account and I put money in there one time, but I got the machine 1 million times. What will happen to the bank account?
Deplete.
Decrease. Why? How much money are you going to have in there after a while?
It's being taken away, withdrawn, decrementing. So sorry, in the example with 1 minus. So the numerator is going down by 1 and the denominator is going down by 2.
I mean, you're very close, but you're not verbalizing the stuff so well. And I don't even know if you ever do a math class like this where you teach a question in so much time. So maybe it's all strange to Uno.
Yes, sir, very strange.
Yeah, but me now go tell you the answer, because if I tell you the answer, then I'll think, and I want you guys to be thinkers. Go ahead, Justin.
Sir, is it because infinity never ends and the constant has a limit?
All right. You see, because you're the closest, I'm gonna help you out. The constant now move, but the infinity is getting larger and larger. The constant now move. So that one day I go stay 1. But the variable is infinity. But it's not just infinity, it is infinity square. So the 1 year now move, but the 1 year move. So I have money in the bank. I have $1 million in the bank. But I've gone to the machine a gazillion times to draw money. There is going to be how much money left in the account after a while?
0.
0, sir.
0. 0. Nothing now go there. Because no, if there was a variable in the numerator, I could say that the variable in the numerator is moving at the same speed or the same time or the same rate as the variable in the denominator. But in the numerator, you notice the numerator here says a constant also, and this is a constant, and this is a constant. So constant means no change. So there is nothing moving, like some of us have credit card, and we get the credit card and we get $1 million limit. And I say, come, we are good. And you buy and you buy and you buy and you buy and you buy. And you say, no, man, I have $1 million, man. And you swipe one time, decline. You say, can't decline and come have $1 million, but you never put back no money on the card. So the card zeroed. Go, Justin.
To me, I get it now, sir. That means if you put a meet and you continue going at it till it done, so zero go left.
Same way, so.
Oh.
Same way, so,
Sir,
Papa.
is like the constant just stuck, but the bottom the denominator got
Same way,
still
so.
go on.
Same way,
Sir,
so,
you know the thing is, sir, me did say it, but me did mute my mic off of the headset.
that means never say it then. You say it to yourself.
Yeah, we never did say it then.
Right. But that's a point. This is not moving. So every time you get to this stage in your calculation, you will get to a point where you're going to have a constant. And that's why we divide by the highest coefficient and then we do the cancellation. You will get to a point where you're going to have a constant and the variables moving all over the place. This now move, but that a move.
Sorry, question.
Go ahead, Papa.
So you say if the numerator move at the same rate as the denominator, then something could have worked out. But if it for the case where it's infinity, if it's infinity or infinity, we need to go back to it being indeterminate.
No, because indeterminate, we would have found that from up top. And indeterminate, we just putting in the value of x directly into the function. This year, 1 year now, we are actually, remember I said to you that when the function is indeterminate, we do one of three things: a simplification, a rationalization, or a factorization. Are we factorizing anything here?
No, sir.
No. Are we simplifying anything here?
Yes.
Yes, we are. So this is a simplification that we're looking at. All right? Simplification. All right, let's go. Let's continue. I hope you're getting it enough. So therefore, this one is going to be this one, and I put it in blue because I want to see it. This 1 over x squared is going to tend to 0. At some point in time, it's going to get to 0. Incidentally, let me ask a question before. Oh, Jesus, Lord, help them. Before you respond, think about the question. Look closely at 1 over x squared, 7 over x to the 4th, 6 over x, and 2 over x to the 4th. And tell me which one or ones of these will go to 0 quicker.
This 7 over x the 4 and the 2 and the x 4.
Yeah, 2 over x to the 4.
All right, very good, Andrew and Damoy. And tell me why though.
Because the x is the infinity, and if the infinity is, what is the word for the 4 again? I keep forgetting the word.
Exponent.
Exponent of the 4 is higher than the exponent for the rest of the other. And so the infinity is a larger infinity compared to the other ones. Right?
So Damoy, I think you have gotten this. Your response is excellent. And I'm proud of you. Just make sure that you keep watching closely to what is happening. Very nice, Papa. You're right on point. Let me repeat what it is that he says. Let me repeat what he says. He says, sir, the 7 over x to the 4th and the 2 over x to the 4th will go to 0 quicker than anything else. Why, Damoy? Because x to the 4th is the largest term with exponent, so it will go to 0 much quicker than all of these. Let me ask an obvious question now. Which one will go to 0 slower or the slowest?
6 over x.
All right, want to catch it now. Want to catch it. Want to catch it. Very nice. Want to catch it. Very good.
So naturally, just to ask something really quick, naturally it would be the one that goes to 0 fastest would be 2 over x to the 4th. And then it would be, if we're just looking to get it in an order, then it would be 7 over x to the fourth.
No, man. The 7 over x to the all right. Taji, hold on to that question. Pictorially, we're gonna have a conversation. So you can answer your own question. I'm coming back to you, Papa, in 2 seconds. Literally in 2 seconds. All right. So let us go. So this goes to 0, this goes to 0, this goes to 0, this goes to 0. Sir, how you know all of them go to 0? See there, man? Boom, bam, boom, bam. The same something we have right here. So we say it go to 0. So we're now replacing it as 1 minus 0 plus 0. See there, so boom. 2 minus 0 plus 0. See there, boom. And 1 minus 0 plus 0 is 1. And 2 minus 0 plus 0 is 2. So therefore, that limit tends to a half. Everybody see that?
Yeah.
All right. No, everybody see that? It's only Taji alone and say no.
Yes, sir.
All right.
Sir,
Cool.
just,
Yes, sir.
sir, wait. I get the 1 over 2 because they are constant, they don't have any denominator. Someone say able to get that. And the rest that have the denominator with x over 2 or x whatever, they all turn to 0. That's what they're saying. And the 2 constant that doesn't have any denominator, you're able to get the half. Okay, you can move on now.
All right. Who is it again? No, Jesus, Lord help me. Trust me, I think I'm very slow this year in getting the names and the
I think you're looking
voices.
for TJ.
Yeah, Taj, right. Thank you, Chris. Yeah, Lord, I'm getting there. I will get there by next week, hopefully. All right, Taj. So you're saying then that the 2 over x to the fourth goes to 0 faster than the 7 over x to the fourth.
Right.
Okay. All right. So let us play around with some numbers. And I'm going to spend a little time on this because I have another question for you to work on for me. Let us have a little conversation. So you notice this 1 over x squared and the 7 over x to the fourth and the 6 over x and 2 over x to the fourth are exactly the terms up here, so don't.
Yes, sir.
Okay, so I don't change them. I just want to make that clear. And then now, just to concretize, since we're working with pure abstract something a while ago, just to concretize the explanation, I wanted the explanation to be on point. You catch it. I'm going to play around with some infinitely large number. And I'm going to start with 10. 10 squared is 100. 1 divided by 100 is going to be 0.01. 10 to the fourth is enough. And 7 divided by enough is going to be 0.0007. 6 divided by 10 is 0.6. 2 divided by 10 to the fourth is 0.0000. So you recognize that this one, if you round off, you get 1, don't it?
Yes, sir.
So that one is slow. Slow bad. But we kind of figure it out. So this is the slowest. Now Tajay says, sir, say that one to go to 0 quicker than the 1 year so. And we're gonna ask, we're gonna have him respond to his own question. If it's 100, 100 squares is going to be enough. 1 divided by enough is 0.0001. 100 to the fourth is enougher. So it's going to be 7 over 0.000000007. This one is so slow. Following the trend as the others, but it's slow. 0.06. Oh, but sir, if you round this off, you can get 0.1. Oh, this one is getting closer to 1, sir, but it's taking a longer time. Because I want to reach 0 long before the one. The one have to wait until it reach 100 for reach 0. The one to reach 0 from 10. Can you see that point?
Yes, sir.
Yes, sir.
And then I want to know I'm gonna move at the same rate as this one. At the same rate. If it's 1,000, 1 over 1,000 squared is 1 over plenty is 0.000001. But 7 over 1,000 to the fourth is plenty, enough. 0.0000001. 0.000000007. Can you agree that this one and this one moving at the same rate?
Yeah.
Okay. And if I put 10,000, the amount of zeros, I can't even bother talk about it, we just write it in exponential form. Standard form. So this becomes now 7 times x to the negative 16, 2 times x to the negative 16, poor fellow, 6 times 10 to the negative 4, and 1 times 10 to the negative 8. All right, so Taj, which one of them moved to 0 fastest?
So based on, I would like to think that they both move to 0 at the same time based on the explanation.
They actually do, you know. They actually do. But when you look at it on paper now, which one do you think is closer to 0?
It's definitely the one that I mentioned, the 2
The 2
over
over
x
x
to
to
the
the
4th.
fourth. Right.
Precisely.
But you understand my point though when I say that they are moving at the same pace?
I do.
Right. So if I really want to nitpick that the onion rings in my burger were not cut evenly, put the darn onion ring between the something and lock the buns together and bite it, you're not gonna know. So if I really want to nitpick, I can say to you, yes, this one here, I agree, moves to 0 faster because this is 2 and 2 is closer to 0 than is 7. But really and truly, they are moving at the same pace. How you know they're moving at the same pace, Sir Sitter? Times 10 to the negative 16 times 10 to the negative 16. So the only thing now that I have to compare is the 2 and the 7. So it's nicer to compare these stuff. So yes, this one will move faster. However, we're not looking at that. What we're looking at is the denominator.
Hey,
And the
it's the
denominator
pace that
tells us
they're moving essentially.
right, right. Everybody understand what does that mean right here, sir?
Yes, sir.
Yes, sir.
Yes,
All
sir.
right, good job. All right. I am giving you one to do for me now. And I'm telling
Sir,
you, go ahead.
before you move on, could you scroll up to the top real quick where the solution is to the half? Not there. Right there. You can move on now. Thank you.
All right, cool. No problem. Now hear me out. I think you guys are really following what is happening. I really am. For the ones that are talking to me, I'm getting into your headspace and I see where it is that you're going. There are some of you that have not unmuted to say a word to me from night evening start. But that's fine. To your detriment. I'm projecting number 8. I'm going to give you 5 minutes to work through number 8 for me. And
5 minutes, sir.
okay, I'll give you 4 minutes to work through number 8. You're saying that 5 minutes too long, don't?
5 minutes. 2 starts. 6 to door.
All right, take 6. On the mark, get set, go.
Sorry, this is
Julian, you got the explanation to what you put in the chat? Okay, Julian not responding to me. Why am I seeing 24 students in the class though? That needs to be sorted out. Mm-hmm. How we stay? Anybody get the answer?
Yes, sir. Yes, sir.
What you got for the answer, please?
Sir, I got one.
Okay, Julian. Anybody else? Alvin, what you got?
The same, sir.
Very good, Logan. Lecarno, you can't drop asleep in a class. Wake up. Somebody call him for no, please, and wake him up.
I'm still there, sir.
Wait for the answer.
One, sir.
Okay. The more what you get?
One, sir.
Shanti, what you get? Evan, what you get?
Sir, I'm there still try to work out.
Okay. Matthew
hear
A,
me?
what you get? I heard the puppy. Matthew A, what you get?
Sir, I'm a bit confused. Are we just showing that the answer is one by breaking it down and get the answer?
How would you come to that conclusion, Logan?
No, because it already said equal to 1.
What did I say when I gave you the question, Logan?
I remember.
You don't remember? Anybody can remind Logan what I said when I gave the question?
Let us start work it out and get it.
Right. All right, so that's my first step, Logan. I want to place the answer there so that it can be a guide for you to work to see if you get the same answer as I did. So there
Oh,
goes the working
okay.
out now. See?
I already got the
Sir,
working out and the answer, you know.
Mhm.
I was just saying that, do you want us to like break it down
Hold
and
on,
see if we
sir.
get the
Wrap up,
same
please.
answer? That's
Sir
what I
Sean.
indicated.
Sir,
Yes, Ninja.
I said I worked out up to where you showed me a while ago. I'm kind of
Mhm.
stuck. When I look on that and I say, yeah man, but I'm on the right track still.
All right, so I'm looking for the highest term, the highest exponent in the question. The highest exponent in the question is,
X to the fourth power.
X4
and it occurs how many times?
twice.
In the numerator and the denominator, don't.
Yes.
So that means I'm going to divide every term by
X to the fourth.
x to the fourth. Good. So tell me if you agree with this line here.
Yes, sir.
Yes, sir.
Yes, sir.
I break it down. Do you agree with this as the final result after I break it down?
Yes,
Yes,
sir.
sir.
Yes.
Do you agree with my statement now that I can tell you without proving it that 1 over x squared, comma, 9 over x, comma, and 1 over x will all tend to 0?
Yes, sir.
Okay.
All right, small problem, sir.
Mhm.
I'm still not set that part there. So I have the 1 over x squared, I have 9 over x, and I have 1 over x. But for some reason, I have one more 1 over x, sir.
How?
I look by yours, I'm gonna see it.
The x to the fourth cancel out in the papa. In the numerator, and it also cancels out in the denominator. So there's only 3 supposed to have. 1 over x squared, 9 over x, and 1 over x. Look back at it, basic.
Now look, sir, man, look. So the last one we're supposed to have was the x squared over x to the cube divided by x to the fourth exponent, correct?
Mm-hmm.
That definitely have that, sir. But unfortunately, me have 1 minus 1 over x squared minus 9x all
9 over
divided
x.
by
No, not 9x, but 9 over x. Watch my spotlight. You said 9x. It's supposed to be 9 over x. Angel, talk to me now.
Yeah, man, I think that there's some mix up, sir.
Right, but what do you have on paper? Is it 9x you have
Yeah,
or
man,
9
a
over?
9x. No, man, a 9x me have.
No, man, that wrong, man. It's supposed to be 9 over x. Look here, let me show you. Remember, you know, this is what we have. 9x cubed over x to the fourth. All of the x cubed can go into x to the fourth and leave x times. So you're supposed to have 9 over x.
Right.
What do you have for the denominator?
1 plus 1.
1 plus 1?
Unfortunately, sir. Never have
Watch
the
this
x
now.
so.
This is x cubed over x to the fourth. All of this x cubed can go into x to the fourth and leave just one x. So it's supposed to be 1 over x to the fourth. Sorry, 1 over x. And we have the 1 over x right here. So the same explanation that I gave you for the 9 over x is the same explanation we're going to have for the 1 over x. And then now we can make a bold statement. You know that you have to write that statement to get the mark though. Say the question carry 5 marks and I don't say that statement to get in 4 out of 5. Because you can't just make something them disappear without you telling them that. As x tends to infinity, all of them constants with the variables, they all tend to 0. They all tend to 0. So therefore, you're going to have 1 minus 0 over 1 plus 0. So it tends to 1. Comfortable so far?
Yes, but you're going fast for me. I understand,
Mm-hmm.
but you're going a little bit too fast, but it's okay.
Right. Chrissy, I'm gonna give you
Because I'm still working the question, you know. I'm at the part where I'm canceling out the ones that are similar.
mm-hmm. All right, no problem. Not a problem. Not a problem, my love.
Sir, quick
Yep.
question.
Mm.
Wonder if it's me not seeing it, sir. So where you have the x squared over x4, how you get the 1 to be over the x? Just that more no? Because you cancel out and go into the next one, so wouldn't it just be x alone?
Kyle, you talk about the partner, the pink?
No, exactly where sir is on right now, that matter.
Oh.
Wouldn't it just be x alone?
All right, Kyle,
Yes, sir.
you were at the same place that Locarno was at on Tuesday. Locarno,
Yes, sir.
you heard the question that Kyle asked?
No, sir.
Kyle, can I ask the question again, please?
I'm asking, you cancel out the x squared into the x4, so wouldn't it just be x alone? How him
Rings a
get
bell.
x over 1?
No,
It rings up.
it wouldn't be that because you're subtracting the 2 from above from the 4. So you'd have the remainder 2. That's why you get the x squared. And you'd have x 1 up above.
So I responded to Locarno when he was doing the limit because he was doing the same thing last class. So I have watch me here because this is the exact point that I worked out just to the right. It's like I knew you were going to ask a question, Kyle. X to the third divided by x to the fourth. This is what you're querying, right, Papa?
Yes, sir.
Good. See it here? X to the third divided by x to the fourth. X to the third is just simply x to the fourth. But in x to the fourth, I can get what a x to the third, and then I'm going to be left with one of the x's. Talk truth.
Yes, sir.
Good. When
X to the
this
one is one.
cancels this one, x to the third into x to the third goes how many times?
One time.
Theta, so boom.
Oh, all right, sir. Thanks.
Yeah.
Oh, you get the negative one, sir.
It's
Sir, you
just
can
it's
show
just
back up.
it's just it's just a law of indices that I'm just showing off on you to say that 1 over x is the same as x to the minus 1. You will come to that a little later on in the course. You don't have to pay that much mind now. All right. Chris, you're saying that I'm
Sure.
moving a little. Go ahead.
I'm stuck.
Okay.
You see, I understand the part where we break it down up to where we cross it off. I'm not understanding how you got to the section in the purple. I'm not
Purple?
understanding that section.
You don't understand this?
No,
What you're not understanding?
where it comes from.
Where this come from?
Mm-hmm.
No, man, I was taking out
Wait,
one example. I was
I
just taking out this.
understand. Okay. Because I
I was just taking
understand.
out. Go ahead. Sorry, you go ahead.
Because I understand for the x over 3, I'm thinking that's because they're the most reoccurring.
No, 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 no. Hold on. So I extracted just one example to demonstrate how it is that I got one of the fractional forms. So this is x to the third. This is what I'm extracting. X to the third over x to the fourth. So I just extract x to the third over x to the fourth just to show you how I did my cancellation so that I can arrive at 1 over x. So x to the third over x to the fourth. See here, boom. X to the third over x to the fourth. X to the fourth is the same thing as x to the third times x. This x is raised to the first power. Discrete math and algebra. When I'm multiplying and the bases are the same, I add my powers. 3 plus 1 is equal to 4. But I wrote it this way because I want to show you that the x to the third in the numerator cancels exactly out with x to the third in the denominator. But here, oh, I'm going to say it. How many times can x to the third go into x to the third? 1 time. See to yourself, boom. And how many times can x to the third go into x to the third on here? You can say 1 time. And 1 times x is, boom, x. Don't worry about this conversion just yet. Little later, I'm going to come back and say, yo, remember this? See to yourself.
Thank you, sir.
No problem. I was going to, I'm still going to come back to you, Christian, because, all right, let me not trouble you, Christian. Let me give you that question. So I'm telling you that that question is going to be positive infinity over positive infinity. When you get the questions won't tell you that it's positive infinity over positive infinity. No, you have to go work it out. And when you work it out, you're just going to do something mental to say, okay, it is a fractional form. I have infinity over infinity. I mean, it's tending to infinity. Chances are it's going to be infinity over infinity. Not chances are. It is going to be infinity over infinity. Once you're talking, once a function is going to positive infinity, it will be positive infinity over positive infinity based on the arrangement of the function and the variables in the function. And then now you are going to be doing the regular test that I have done. So therefore, I'm going to ask you to work on that one for me, please. I'm going to give you another 5 minutes. Chrissy, I want you to work this one faster than the one before, my love. Promise?
I'll try, sir.
All
No
right, good.
promises, but I'll try.
No, man, promise. You have to promise me, man. I want my promise. All right. Let Karna want you to be working, Papa, please. All right. And those of you who are following, Julie, wake up. I know it's a Friday, guys. And you guys are, it's the end of the work week. But you can't come calculus class. I don't know why they put class on a Friday. Like, seriously. But anyhow, when you can't come calculus class and come sleep, when I have to be alert. By the way, let me ask you. On learning, on understanding what I'm teaching, by the way?
Yes, sir.
Yes,
Understanding
sir.
fun.
Yes, sir.
Okay, go ahead.
The new question is kind of confusing.
All right, 5 minutes. 7:38. All right, yeah, 5 minutes. All right, 6 minutes.
We finish, but my answer not look right at
Warm to it.
We get 0 because there's
Yes.
no constant.
we get
What?
0, 1.
You get 0, 1. I don't find no constant in this. So everything does 0. So probably that's what I mean by positive infinite. What call it?
Infinity.
Yeah.
Okay. Kyle, where you get? Kyle, what did you
So I
get?
didn't say I get anything, sir.
All right, somebody. So who was the mail that said they finished? Them think they finished. Oh Jesus, I need to get these voices.
Yes,
Somebody
sir.
respond. Okay, it was you, Andrew. You said that you finished?
You me do something wrong. I see what me do wrong, sir.
No, tell me you give the answer. Tell me answer yes, so far.
I cancel out the x to the fifth over the x to the fifth. So that.
All right. Anybody? What's the answer you get?
0.
You get 0? Okay.
Teresa,
What is it, Ashanti?
3.
You got 3. Okay. Alwyn, did you answer me?
Yes, sir.
How much you say you get?
0.
0. What was the line before the 0?
Repeat.
What was your line before the 0?
Oh, 3 over x, 4 over x squared, 7 over x to the fifth, and 9 over x to the 9 over x.
And you just get so 0 so? One dry 0? Where you get?
Yes, 0 over 0, yes, sir.
You get 0 over 0?
Sir.
Sir,
Yo.
I have 0 over 1.
X over 5 over x over 5. X to the fifth over x to the fifth, sir.
That's it, 0 over 1.
Oh, that Christian?
No.
Okay, Chris, you done the one to do. So you do that one first?
So you're pressuring me, sir.
I'm pressuring you. Very nice. I'm happy that you feel pressured. You don't feel pressure yet? Hey, wait until I get going further. Sorry. Andrew, was that you talking a while ago? Before, Christian? No?
Who said, sir?
No, sir. I said 0 over 1, sir.
Yeah, man, I heard you, Raji, and I hear you, Ashanti. Andrew, what you said the answer was?
Sir, I was asking about x to the fifth over x to the fifth. No one that. So I said the answer would have been 0 over 1.
Okay, 0 over 1. And what's 0 over 1?
Sir, what is 0 over 1?
0.
Indeterminate.
0. Listen, Andrew, you know, sound like you sure yourself, Andrew.
Sir, I said indeterminate.
If I knock you out, you say, boy, say 0.
0. Oh, yeah, that about in a divisional term.
Yeah.
0 divided by 1 is 0.
Yes. Now come tell me about not
I
indeterminate.
see.
Sure. Your Friday
Sir.
evening dinner now go taste good. Yes, please.
So what you guys talking about?
Math.
I know it's math. So what you're talking about 1 over 0?
No, so I never say 1 over 0. I say 0 over 1.
Oh,
We're
0
working.
over
We're talking about the solution. What you got for your answer again? What you got for?
Everything. I didn't get any constant, so everything goes 0.
Okay.
Yeah. I was thinking if you guys talking about x over 5 and x over 5, that does cancel with each other.
Mhm.
Okay.
Yeah, that's exactly what he says.
Oh.
But, so you weren't getting any constant at all. That's what you're saying?
Yeah, I don't get any constant by itself without the x variable.
Okay.
So what's the
We just
answer,
said, you know,
sir?
sir, 0 over 1 for true.
All that.
Talk to sir, finish.
Okay.
Just remember example you showed me the other day.
Mm-hmm.
I know that's one I thought, but no, like it's 0 over 1. So what's the answer? 0 over 1. Okay.
For those of you who got the 0 over 1, I'm super proud of you. And I'm going to say it one more time. I have no problem with you answering me and getting the question wrong. Where I have a problem is for those of you who are not speaking to me in the class. What is happening, guys, is that you're sitting on your misconceptions, believing that they are true. And because you're not verbalizing it so that you can tear your misconceptions apart, you're holding on to it for dear life. You are going to fail.
Sir, hold on
So,
a pause.
so before you start tear us down, answer me this question, please. So the 5 over 5.
No,
The
you press pause. Before
Yeah.
me start tearing you guys down. Do I ever come to class and tear you down? No, you have to qualify that. I'm not tearing anybody. Am I tearing you down? I'm not tearing you down. I'm only saying that if you don't speak to me in class so that I can hear your misconceptions, you're going to tear yourself down. So all I'm doing is to encourage you to talk to me, participate in class, so that I can be able to correct your misconceptions. Because when you hold on to your misconceptions, you hold on, remember your misconceptions are those that you developed, or that they were passed on to you, and you hold on to that. And not care what nobody want to tell you, and that you believe. So you can go into the exam and go into the stuff and go and say, well, the teacher never did teach because me failed. So you have to allow me to be able to get through to you to undo those misconceptions. So it's not tear me turning on my love. Don't say that. You're asking a
I
question, somebody.
apologize. I apologize. So
Yeah,
it's all the
you can
same
yourself.
me.
Mm-hmm.
So the x/5 and x/5, even though it cancel out each other, it's still 1 as a constant.
Yes, ma'am.
Okay, so that's the part I didn't get.
Right. And
Okay.
you're not the only one. So Lecarno had that issue, and then somebody today had that other issue, and then you are talking about it now. So remember now, when I divide x to the 5th over by x to the 5th, it don't just disappear so in thin air. It's going to be 1.
Okay.
Put it this way, Loki.
Mm-hmm.
I have 160 Jamaican dollars.
Mm-hmm.
I have 160 of them,
Mm-hmm.
and then I go to the bank and say, yo, give me a US dollar. I'm going to get one diggy dollar. One diggy dollar. So it's not that I give them the $160 and say, how much is it for the US dollar? And it's 160, and then I leave it out nothing. I have to leave it something, because 160 to 160 is 1. So I'm going to leave it 1 US dollar. Follow me?
Yes.
Okay, good.
Okay.
How are we feeling, guys?
We're feeling pretty good.
Good job. I have one last one for you for the day.
Sir, hold on, man. Before you move,
Just rejoining.
You're not system raise, man, sir.
Sorry, I didn't see that, Nigel. Go ahead, Papa. Somebody said before you move.
Explain.
You're low, though.
Me?
You're kind of low. Go ahead.
Yeah. Any better, sir?
Yeah, man.
All right. You can explain the part where you have, like, what I call that? The third section with the 3 over x. Because I have 3 and 1x minus 4 over x squared. So it's like I catch it, but I not catch it, sir. I'm not gonna lie.
Tell me what you have for this line. What's the first term you have in this line?
I have 3 and then 1x. 1 over x minus 4 over x squared minus the 7 over x to the 4.
You have 7 over 4. You have 7 over x to the 4th?
Yes, sir.
So let me ask a question. When I have
no,
three
lies. No, sir. I have 7, but we never have the lower part yet. Come it's stuck right there, so.
Okay.
So the 3 over x the way I have, sir. Me have,
No, let me ask you a question.
yeah.
What are you dividing through each term by?
X to the 5.
X to the 5. All right. So that means this line, you're okay with it. What you're saying to me now, Morgan, is that you have Mason, is that you have an issue. Canceling. Work with me. The last time I'm going to show you. And the rest of you who are not following, work with me. How many times do you believe all of x to the 4th can go into x to the 5th?
Yes, sir.
Only what remainder?
1x.
See, Tessa? Boom. 1x. So since all of this can go into all of this.
Sir, we're most there.
You not see it?
When I see a pointer, sir, negative. All right, see it now. Yeah.
So all of x to the 4th, you say can go into x to the 5th. So since all of this can go into all of this and leave only x times, that means this is just going to leave 3 up here. So that's going to have 3 over x. Can all of x cubed go into x to the 5th?
Yes, sir.
And leave what?
X squared.
Good job. So we have 4 over x squared. See it right here? So 4 over x squared. Because all of this x cubed is subsumed into this. Can all of x go into x to the 5th?
Yes, sir.
And leave what remainder?
So it'll be x to the 1 minus x to the 5 minus x to the 1, sir. So it'll be x to the 4. That's how me work it out, sir.
Yeah, man. You're right. It's going to be 1 minus 5. So it's going to be x to the 4th. All right? So you can have 7 over x to the 4th. X to the 5th over x to the 5th is what, Mason?
1. X cancel.
That's why I have the 1 here. Can all of x go into x to the 5th? Same question I asked up here, so.
Yes,
and
sir.
the answer is a yes. So we can have 9 over x to the 4th. As this, and this, and this, and this tends to infinity, we're going to have all of them there going to 0. So this is what I end up having.
Quick one again,
0.
sir. For the question you have positive infinity over positive infinity, indeterminate, right? Is that positive infinity a trough because it never used back nowhere down here, so?
No, man. So an indeterminate form can be one of 3 things. 0 over 0 at this level. 0 over 0, positive infinity over positive infinity, negative infinity over negative infinity. Because you're saying that you're asking me if the positive infinity over positive infinity is a throw off. But did we use the 0 over 0 again in other questions that we did?
No.
No.
Good
What
question.
did we use the 0 over 0 to show?
That is indeterminate.
What are we using a positive infinity over positive infinity to show?
Same thing.
I will then move to a question next class. Negative infinity over negative infinity. What am I showing?
Same indeterminate, sir.
Yeah. So there are 3 different forms that you're going to be introduced to here. The positive infinity over positive infinity, negative infinity over negative infinity, and 0 over 0. So once you work your questions and you get those as
indeterminate
points, it tells you that it's going to be indeterminate. And it tells you that there's something else you have to do. So we're doing a simplification. And the simplification will get me my answer the way I want it. All right, I'm going to pause here and I'm going to ask you, how was the class?
So it was good.
I learned
Right
a
up
lot,
for
sir.
you.
All right, sir. You start separate the boys from the men already, sir.
Same way, sir. And the girls on the women.
Oh, yes. But may I get there, no? Nah,
Just
get
as
there.
nah, like it's a class a whole lot of time better than the previous classes.
Yes,
Okay.
sir. Best class of all.
Okay.
It's a big improvement.
Okay. And you learn anything in the process?
Of course, sir. I learn a lot.
Yes,
I
sir.
mean,
Yeah,
more
man.
what things we learn today.
There's no
Sir.
way you can teach a class, sir. And
I just
we say what
because
I
we
learn.
hungry, I eat half the one.
Sir, just one question.
Yes, Logan.
Yeah. What kind of drum we can use this with?
Lord Jesus. Me tell you next class. me tell you next class. All right. No, let me just warn you guys. Christian said it. Sir, you're moving now. Let me just explain what was happening in the first set of classes. I pretty much was giving you formula. You know, when you have young baby and you mix up the powder something in a warm water and give them for drink and them love it. That's what I was giving you guys. Because I wanted to whet your appetites for the mathematics. All right. Tonight class, you may think that is a whole lot, but you don't see anything yet. It's going to get a little rougher. All right. So I'm saying this to say to you, I'm actually trying to finish off this unit 1. Still don't finish off unit 1. It's going to get rougher. I'm going to come to class and you're going to say to me, sir, it is rough. But guess what? When you put in the sweat equity and you put in the extra work and you're understanding, come next class, I'm going to be building. Sir, what are you going to build towards, sir? Okay, thanks for asking. I'm going to be building to something that looks like this. Indeterminate form, including negative infinity. So you have to know, go have a concept of what it is that you're going to substitute when x tends to negative infinity. Right? When x tends to negative infinity. So you will have to know and understand what is happening. But guess what? I cannot move on to negative infinity come next class, God's willing, if it is that you don't revise what it is that you're supposed to be revising for this class. All right? So it's going to be very important that you put in your work. When you put your work in, trust me, you will get the results out. So all of what I was doing before, it was deliberate to whet your appetites. What I'm doing now is giving you dumpling and banana. Logan, to answer your question, Mom.
Yes, sir.
When you do subjects like these, what it does, it increases your mental capabilities and your reasoning skills and your logic. So it is that you can do stuff. For those of you who are in programming, you're using C++ or you're using Python or whatever it is, you have to write codes. And if you make a mistake with one something, it will never work out. Right? So if you're looking at your AND gate, NAND gate, NOR gate, and if it is that you don't do something properly with the NOR gate or the NAND gate, which is a combination of 2 of the other gates, you are not going to be successful in completing that program. So you have to be very precise in what it is that you're doing. Yes, Chrisan.
I was asking a favor before you leave, if you could I do my notes on the computer, so I just wonder if you can look at my working notes and see if it's okay.
Okay, I will look at that. All right. You sent me something?
No, I didn't send it. I was just gonna share my screen with you real quick.
Okay. Go on, mommy. Wait for you. Okay.
There it is, specifically this section here. I just says if the statement is okay or this statement, no matter which one. If it's either this statement or this statement. Sorry.
What do you want me to look at?
The statements, if it's okay. Can you say it's valid or 1 mark or so?
Oh yeah.
Fine.
That's fine.
All right, thank you.
Yeah, man, you're welcome. All right, best guys, big up on yourself, study hard, put in the sweat equity, and you should be fine. Talk to you on Tuesday, God's willing. All the best.
Same to you, sir.
Yes, sir. Big ups. Have a blessed weekend.
You too, Pops.
Sir, enjoy your weekend, sir. Many thanks
Come on,
again.
easy. Cool, cool.